So good morning, guys. Today, what I'll be doing is I'm going to be covering 11.1 and 11.2. We'll be spending our time talking about how do we describe chemical reactions and how do we write out those chemical reactions. Um, I'm going to try to finish both of these sections today with giving you all the optimal or maximum amount of time for you all to continue to work on your assignments as far as the book is concerned from the book and for the chapter work that you all have available. Remember, your chapter work will be due before this week is over, and the expectation will be that you'll upload that before the week is out. So, without further ado, let's set to talking about what's discussed in your book. So when you're writing chemical equations, these are some of the things that you all have seen so far, but the way that you all should think of a chemical equation is as a sentence, okay? A plus B yields AB or ABC, or A plus B plus C equals AB, or so on and so forth. It's the same as if you were baking bread. When you add several cups of flour to a mix, the thing that you would expect to have at the end is some type of an end product or multiple end products. And we're doing the same thing in chemistry. However, in chemistry, we designate how much of each we have and how many of each that we have and what we end up with after we put those things together. So if you're looking at strictly the left side of the equation, the left side of the equation is what we call our reactant side. The right side of the equation is what we call and consider our product side. So our reactants are over here, our products are over here. So if you were to put iron and oxygen together, iron oxide is going to be your resulting, but your reactants are iron and oxygen. Your product is iron oxide or iron 3 oxide. And so that's the simplified way of writing an equation. Now there are a couple of things that you all need to keep in mind. You cannot, first of all, end up with more than you started with, or start with or end up with less than you began with. Everything has to be balanced, and that'll be something that we'll discuss here in this section a little bit more later. So when we're writing chemical equations, there are certain things that have they mean certain things when we're writing them as a sentence. All right. So remember, reactants go on the left, products go on the right. There's a yield sign. That yield sign, simply put, is an arrow. And so if you use two separate things, the addition sign means that you're putting those together. The yield sign is an arrow that goes from one side to the other, one side of the arrow to the other. If the reaction is reversible, the arrows will go in both directions. So you'll have one arrow that goes to the right and the other arrow that goes back to the left. Out beside any of your reactants or products, you'll have these little symbols. The S stands for you're using it as a solid. L stands for you're using it as a liquid. G stands for it being as a gas, and AQ stands for it being in aqueous solution, or it means that it's in water. Okay, so things that are dissolved in water, we say that they're in aqueous solution. What?
Are you supposed to be showing us something? He was explaining, he was like, this little symbol in there, are you supposed to be showing us something?
Yeah, I am. Apparently in Zoom I did not share my screen. So hold on just a second. So do you all see my screen now? Can you see the screen now, Mitchell?
Yes, sir.
Okay, cool. So you got S for solids, L for liquids, G for gases. Aqueous means that it's in liquid solution. You're going to see this aqueous solution an awful lot when we talk about acids and bases, just because in order for it to be an acid or a base, it normally has to be dissolved in water. This is a triangle over an arrow, and this is the word heat over an arrow, and it indicates that there is going to be a change in energy. In other words, if you heat it, or if the reaction takes place and it starts to bubble or boil, or it cools down, you'll end up with the triangle. And then if you have a metal written above the arrow, it means that you're using a catalyst. For those of you all that don't know what a catalyst, simply put, is a metal that's part of the reaction that makes the reaction take place faster, but it does not it's not part of the reaction. In other words, you don't end up with it as the products. If you're using gold or silver, that gold or silver allows the reaction to take place, but it does not directly affect the chemical reaction per se. So whenever we write these reactions, there are some things that we have to know. One of those things is, how do we balance these equations? And that's the next thing that we consider, and we want to make sure that we cover as far as doing things correctly. Because remember what I said earlier, you can't start out with or end up with less or more than you began. In other words, you must break even after the chemical reaction has taken place. So in this example, they use the example of a bike. They say that if you have a bike frame, 2 tires, a pair of handlebars, and a pair of pedals, that will get together and create a single bike for you. Now, if you take a much closer look, you'll notice that they use prefixes when they talked about all of these items. In other words, this is one frame, 2 wheels, 1 set of handlebars, 2 sets of pedals. Yields 1 frame, 2 wheels, a set of handlebars, and 2 pedals. That is a balanced equation. To write balanced equation, the first thing is to write the skeleton equation and then use the coefficients to balance the equation so that it obeys the laws of conservation. When we write skeleton equations, we're just writing down what we see. We don't necessarily add any prefixes, suffixes, or prefix or subscripts. So when you're writing the formula, the rules that you'll follow, you determine the correct formula for all reactants and products. Write the skeleton. Things that are reactants go to the left, things that are products go to the right. Write your yield sign. If they're reactants or products that are extra, you add plus signs in between them. Determine the number of atoms of each. Count the polyatomic atom units, and then balance your equation. Make sure your polyatomic ions are equal on both sides and make sure that all the coefficients are in the lowest possible ratio. And so what we want to do now is we probably want to spend some time working on a couple of these practice problems. So, in a reaction, hydrogen, which is diatomic, plus oxygen, which is diatomic, yield H2O. And just for good measure, I'm going to put G's out the side of these. This water is actually in its gaseous form also. So you've got two gases put together that yield a liquid or a gas, which is water. So in order to balance this out, you've got hydrogen and oxygen. Hydrogen and oxygen. You've got two hydrogens on this side, two oxygens on this side. You've got two hydrogens here, one oxygen here. You've got to balance out this oxygen. So the first thing that I'm going to do is I'm going to add a coefficient of 2 here. That will change this H to 4. That will change my oxygen to 2. Okay, so these are my two new numbers. Now I have 4 hydrogens to 2 hydrogens. I need to make this number of hydrogens on this side become 4. So I'm going to place a 2 out here. And what that does is it gives me a total of 4 hydrogens. So now I have 4 hydrogens here, 4 hydrogens here, 2 oxygens here, 2 oxygens here. My equation is now balanced. And so that is how we work and balance equations. So that is going to be the end of this little short lesson. What I will probably do is spend some more time working with you guys on balancing equations. I'm going to sign off telling you all to be safe. Make sure you wash your hands. If you're in class right now, do not log off. And y'all take care of yourselves. Bye.